Welcome. So we're going to answer this question right here. Let's give it a read. It says, in a factory, two machines produce a particular circuit board. The older machine produces 480 boards each day, of which on average 12% are defective. The new machine produces 620 boards each day, of which an average of 5% are defective. A board is chosen at random and checked. Find the probability correct to 2 decimal places of randomly selecting a circuit board that is produced from a new machine that is defective given that it's produced from an older machine. And then the last one here is that it's defective and produced by an older machine. Okay, so how are we going to approach this question? I believe the hardest thing about probability questions is figuring out what the best way to represent your data is, and only with practice does it become clear what the best method is. Now, what you want to use here is a Karnoff map. You want to say that you have either a board produced from a new machine or a not new machine. And the board is either going to be defective or not defective. Now, we're told that the older machines produce 480 a day. So that means under the old machines, 480. So not new is the old machines, and that's 480. The newer machines produce 620 boards a day. So 620 would go under the new one. Now, this is where we've got to be careful. We've been told that out of the 480 boards produced by the older machines, 12% are defective. So that means here, and I'll put this in blue, this one right here is 12% of 480. So as you can see, this part right here is the probability of the probability of not new intersection of defective. That's kind of what we're thinking of in this space right here. So I'm going to come to my CAS, I'm going, all right, 480, and then I'm going to times it by 12%, so 0.12. And that means I'm going to get 7.6. So then we can say, well, how many not defective machines do the older machines make? Well, then we just go 480, because that's the amount, and subtract that from what we got up here, that. So that's going to be 422.4. 422.4. We could have also said, well, if 12% are defective, that's going to mean the remainder of that percent is going to be not defective. So what's that going to be? 88% are not going to be defective. So we could have gone 480 times 0.88, and that would have also given us 422.4. So it makes sense how this works. And again, if you add them up, you get to 480 as well. So hopefully that makes sense about how I've gone about that. What else can we figure out here? We can figure out how many we will have in total. So 620 plus 480, that will be 1,100. Now we need to figure out this. So out of the new ones, so out of my 620 new boards, we're told that 5% are defective. So I'm going to go 620 times 0.05, because that's 5%. And that's going to give me 31 are defective. So that should be here, 31 are defective. So new and defective are there. And then how many are not defective? Well, I'm just going to go 620 minus the 31 that are defective. And that means 589 are not defective. 589, perfect. And now I can add these together. So 31 plus this is going to be 88 point, that's funny looking eights, 88.6. And this will be 1011.4. So as you can see, by adding them up, I can get it. Now this says, find the probability that the board that is produced from a newer machine. Okay, what's the probability that is going to be produced from a newer machine? So all we had to do for this one really was go, all right, the new machine, it'll be 620. That's it. So nothing too crazy there. Produced from a newer machine. Yeah, 620. So that will be the probability of a newer machine will be 620 over 1100. So that means here, what we're going to do is go 620 divided by 1100. We hit enter and we're going to get 31, but we want it to 2 decimal places. So let's come back up. Let's go control enter, and we're going to get an answer of 0.56. That's to 2 decimal places. I've rounded it correctly. That's going to be my answer there. All right. I really don't like making these videos longer than 5 minutes, so I'll stop here. We're going to use all this working out to answer our next one. You might like to pause it and see if you can do the next one for yourself. I'll see you soon.